Good day students, this is mathematics class for grade 9, chapter 1, number systems. Decimal expansion of numbers. In the last class, we have already studied the first type of decimal expansion of numbers, that was the terminating decimal. So terminating decimal numbers are the rational numbers. In today's class, let's study the meaning of non-terminating repeating decimal. So non-terminating repeating also can be called as recurring decimal. So here the meaning of non-terminating repeating or recurring decimal is, that is, when a number is divided by the other number, the remainder never becomes 0. That is, for example, 2 divided by 11. So when I divide 2 by 11, so here 2 doesn't go in 11, so 0.11 ones are 11. So you'll get 9. So 11 eights are 88. So 11 ones are 11. So again 11 eights are 88. So this goes on, isn't it, students? Yes. So can you see here, it is non-terminating. What is the meaning of terminating? Terminating means it ends. That is, the remainder becomes 0. Here, the remainder never becomes 0, and it is non-terminating. It never ends. And it is repeating or recurring 1 8 1 8. And if I go further again, I will get 1 8 1 8. So it is recurring. So here, such numbers, that is 2 by 11, 2 by 11 is called as a rational number. It is a rational number. The rational numbers are the terminating decimal numbers, the rational numbers, as well as non-terminating and repeating decimal numbers are also the rational numbers, such numbers. So write, when a number is divided by the other number, the remainder never becomes 0. Instead, the numbers of the quotient, this is the quotient, start repeating themselves. Start repeating. So such numbers are called rational numbers. So such numbers are called rational numbers. So did you get the meaning of non-terminating, repeating or recurring decimal? Yes. Few examples. One I gave was 2 by 11. Example, Second one, I can give 11 by 6. You can try dividing these numbers. 1 by 6, get 3 by 11. All these are rational numbers where they are non-terminating and repeating decimal. Is this clear, students? Yes, okay. Now, next let us move to the third type, that is non-terminating or non-repeating decimal. So, what is the meaning of non-repeating, non-terminating decimal? Non-terminating, non-repeating or non-recurring decimal. So here non-terminating, non-repeating decimal is a decimal number that continues, that is never ends, non-terminating. But here the numbers in the quotient, they do not repeat, they are non-repeating. But you saw in the second type, that is non-terminating repeating, we observed that the numbers in the quotient were repeating, but here in this type it is non-repeating. You find different types of numbers, different numbers. So here these types of numbers are called irrational numbers. They are irrational numbers. The first type, terminating decimal, and the non-terminating repeating decimal were rational numbers, but here non-terminating, non-repeating decimals are irrational numbers. For example, okay, let me first write the meaning. So non-terminating, non-repeating decimal is a decimal number that continues endlessly with no digits repeating. Here the numbers in the quotient, they won't repeat. So these decimals, the decimals of this type cannot be represented as fraction. These cannot be represented as fractions. But you found that in second type, that was a non-terminating repeating decimal, you found that they were represented as fraction. For example, 2 by 11, isn't it? Then I told you 1 by 6, all those were fractions. But here you cannot represent this, the third type, as fractions. Examples are root 2, root 3, pi, then root 5, etc. All these are examples for non-terminating, non-repeating decimals. Now let us see the value of this. Root 2 value is 1.4142135623, and it is non-terminating and non-repeating. Here the value of pi is 3.141592. Then the root 3 is 1.732050. 0.00756. So these are non-terminating, non-repeating decimal and are also called irrational numbers. These cannot be represented as fractions. Did you get this, students? Yes, okay. Now, so we learned all the three types of decimal expansion of numbers. Now we all know that real numbers are categorized as two types, that is the rational numbers and irrational numbers. So here in rational numbers we have any number which can be written as a fraction. Any number written as a any number which can be written, any number which can be written as a fraction. For example, now 7. 7 is a rational number. This can be written in the fractional form, that is 7 by 1. Then I have 0.3. I can write in the form of fraction. So 0.3 is a rational number. 1 by 3 is a rational number. Next we have 2.09. Okay, this can be written in the form of mixed fraction. Okay, that is like this. So did you get this, students? Okay, now what are irrational numbers? Irrational numbers are, as I told you all, it is non-terminating and non-repeating decimals which cannot be written as fractions, cannot be represented as fractions. Did you get this? Non-terminating and non-repeating decimals. Non-terminating and non-repeating decimals, and these cannot be represented as fractions. For example, you have the value of pi. Did you get this, students? Yes. So under decimal expansion of numbers, we had three types. That was, first one was the terminating. The remainder, here the remainder was 0. And non-terminating. You had terminating and non-terminating. And under non-terminating, you had two types, that was repeating and non-repeating. Isn't it? So here terminating decimals are rational numbers. Non-terminating repeating decimals are also rational numbers because they can be converted. They can be converted into fraction. They can be converted into fraction. So they are rational. And then you have non-repeating. Under non-repeating, these numbers cannot be converted into fraction. They cannot be converted into fraction. So they are irrational. They are irrational. Did you get this, students? Okay. Thank you, students.